இப்போ வந்து இஎம்ஐயில் ஒரே ஒரு பாயிண்ட் மட்டும் எடுக்கல. என்னென்னா, ஒரு solenoid வந்து such a big solenoid. Imagine one solenoid is such a big solenoid. Okay, another solenoid is a smaller one. You have two different solenoids. The bigger solenoid has, let's assume it is having radius R2, area is A2, number of turns is N2. Whereas the smaller solenoid, the red color solenoid, so let me draw it in red color, has a radius R1, area A1, number of turns N1. But you notice that, do you know that every solenoid is like a bar magnet? And you know that the bar magnet, within the bar magnet, it's north pole, south pole, the magnetic field is always uniform. South north, it's uniform magnetic field. So you know the bigger solenoid is going to behave like a bigger bar magnet, and you know the magnetic field is uniform, and the solenoid or the magnetic field is mu naught into small n into I. That's for a bigger solenoid. So therefore you know that the inner solenoid is lying submerged in the uniform magnetic field of the outer solenoid. So you can find out how the inner solenoid is getting affected by the outer solenoid by writing the number of turns of the inner solenoid into d phi by dt. Number of turns of the inner solenoid d by dt of magnetic field due to outer solenoid into area of the inner solenoid. So minus n1 into d by dt of magnetic field of the outer solenoid is a quarter formula, which is a constant, because you know outer solenoid has got, is like a bar magnet whose magnetic field is uniform. Mu naught into small n2 into I2, where n2 is capital N2 by L2 into A1. So when I group this here, minus mu naught n1 n2 A1 by L2 into di2 by dt is E21. So I know the mutual inductance is this M21. I got it, correct? However, the scientist couldn't find how the outer solenoid is getting affected by the inner solenoid. Why? The outer solenoid is lying in the non-uniform magnetic field of the inner solenoid. Can you imagine this to be a bar magnet? Outside the bar magnet, the magnetic field will be non-uniform. Therefore, you can't write mu naught into small n into I, because you don't know any value. Only inside the solenoid it's quarter. Mu naught into small n into I. Outside you don't know the value. So therefore the scientists couldn't find how the outer coil is getting affected by the inner coil. They got stuck. Why? Because you know it's minus n2 into d phi by dt, which is minus n2 into d by dt of b1 into a2, whereas b1 is non-uniform. Because outside b1 lies outside solenoid S1, and therefore it's non-uniform. So they couldn't predict the magnetic field. And how will they find mutual inductance then? They simply took it as என்னோட சோகம் உன்னை எப்படி தாக்குதோ உன்னோட சோகம் என்ன அப்படியே தாக்கும்னு அப்ராக்சிமேட்டாக எடுத்துக்கிட்டு they just decided that the M12 will be equal to M21, and they continue to write the same answer. Are you clear?
Yes. Okay.
This is one. Okay. The next thing that you need to know is they will give you one very, very important question. There will be a circular coaxial circular coil. One of radius R1, other of radius R2. They'll ask you how. This is current carrying coil. You know, current carrying coil produces a magnetic field. So then there will be a current I1 in this, there will be a current I2 in this, and all that. Due to this, what is the mutual inductance? Instead of the difference between solenoid and a coil is only one turn is a coil, n turns is a solenoid. So I can't treat this as a solenoid. This is only a coil. So let's find, you know that the inner coil is lying in the non-uniform magnetic field of the outer coil. So I can find how the inner coil is affected by the outer coil, which is minus number of turns is anyway 1. Because it's just coil into d phi by dt, which is minus d by dt of magnetic field of the outer coil and area of the inner coil, which is pi r1 square, basically pi r1 square. Magnetic field of the outer coil, you can't write solenoid's formula, because this is not solenoid, this is a circular coil. You know how many students will continue to write it as a solenoid and lose marks? What is the magnetic field at the center of the circular coil? According to last lesson, it's mu naught by 2 into I by A, where A is the radius, which is outer coil. Magnetic field B2 is R2. So you should mu naught by 2 into I by A. In the previous lesson, magnetic effects of electric current. Instead of A, you write R2 because outer coil. So mu naught by 2 into I by R2 be substituted by R1 square. Group it as di by dt. So minus mu naught by 2 I pi R1 square by R2 into di by dt. This is the value of mutual inductance. Not even in your dream you will imagine that you have to write it like this.
Mu naught by 2 into I
by R1 square by R2 is the value of mutual induction produced by inner coil and the outer coil. Therefore, outer coil will also be affected by this only. You don't have to really find because you can't find. The scientists got stuck there, so they assumed M12 is equal to M21. It's very important. Somewhere you would not know to substitute this formula. Other than this, there are lots of other numericals that I've done in that. I'll also tell you certain numericals like this. When the current is increasing in this direction, they'll give you a coil here and they'll also give you a coil here. If the current is increasing, you keep your right hand thumb like this and the curled finger with nails outside. Yeah? Shows that the current is coming from inside to the magnetic field is coming from inside to outside here. It's coming outside here and goes inside here. Correct?
Yes.
It's increasing in this direction, increasing in this direction. You have to counter the change. So increasing outward means you have to produce a flux in the inward direction. So the inward direction, point your thumb, the current will flow clockwise here.
Yes.
Here the magnetic field is increasing in
Outward direction.
Outward direction. Outward it's increasing. So you had to produce a flux in the inward
direction.
Keeping a thumb in inward direction, current flow here. Here it is increasing
in the
inward.
direction.
So you have to produce a flux outward
direction.
So current in the bottom will be anti-clockwise. Induced current. Puriyada? So like this the questions will come. There are many more questions. So there's a question like this, where there will be current I, there will be a wire like this, there will be current I. Okay, can you keep your curled finger in this current's direction? Curled finger shows that the magnetic field of this is B1 is like this, due to I1. Curled finger it be here. So B1 is like this. Okay, let's curl the finger in this direction. The magnetic field will be upward. Can you say upward?
Yes, ma'am.
So B1, this is due to I2. And the resultant will be like this, which is root of B1 square plus B2 square. What is B1? Center of mu naught by 2 into I1 by R1. Plus second one, mu naught by 2 into I2 by R2. Substitute this respectively. If radius are the same, you can write it as it is. Like this, there are many sums which I have uploaded in the video. But where is it? This is not this lesson actually. This is previous lesson. This is not this lesson, previous lesson. We have it in the video. Just make sure that you are thorough with this. Okay? And